I'd like to introduce Martin Hollowell, who's the CTO of SES. He's going to be your featured speaker today. If you have any questions for him after he gives his opening remarks, feel free to ask. John Taylor and I will be around after the briefing if you have any questions about SpaceX. But our focus for this briefing is really SES-9 and the upcoming mission. So we're going to keep the conversation there. And with that, I'll turn it over to Martin to go ahead and get started.
Thanks, Emily. Don't go too far away.
I'll stay right here.
Okay. In case of any tricky rocket questions. Okay, can you guys all hear me at the back? Good to go? Okay, so maybe just a few opening remarks first of all about why SES-9 is so important for us. And I've got my crib sheet here, and the reason for this is we have 7 satellites under construction at the moment. Some of them very large, and I'm getting older, and I just cannot remember the specifics of each one, so I've got my little cheat sheet here. So we're going with SES-9 today. The all-up mass of SES-9, wet mass, is going to be around about 5,721 kilos. The satellite is going to 108.2 degrees east. It's going to be serving our Asian marketplace. It's going to be the largest satellite that SES has in the Asian marketplace. This is why it's so important for us. Really, this satellite is now the first of 7 satellites that we're going to be launching. And that's why we were here 2 years ago. We say this was the first commercial launch that we did with SES, with SpaceX. You know, now we're here again. It's a new phase of SES. It's a new phase also with SpaceX. We're excited about that, and we're going to move forward over the next couple of years. And just to give you a feel for that, we will also be launching 2 more satellites, SES-10 and SES-11, both with SpaceX this year. So that's 3 launches with SpaceX this year. So I think it's good for us, it's good for SpaceX, and it's also good for the state of Florida as well. So we want to try and bring you some business as well. And it doesn't end there. It doesn't end there, because the following year we'll be back and we have more launches also with SpaceX. We have 2 more launches with SpaceX, with SES-14 and SES-16. So we have a really significant relationship with SpaceX. And I'm going to talk to you a little bit about how that relationship is developed and how well we've worked together with SpaceX. Just going back to SES-9 for a moment, this satellite is, as I said, it's going to be for Asia, Southeast Asia. We have 7 missions on board the satellite, and basically the usage of this spacecraft is broken into 4 verticals. We have video, so we're going to be developing the video marketplace there. We reckon that we'll be extending our usage by around about 22 million homes in Indonesia and in the Philippines, developing the high definition marketplace there. We'll also be putting in support for enterprise type data services, so conventional VSATs, etc. We also have a mobility package on board. Predominantly this is for maritime services, so we have an Indian Ocean beam which will be used for the shipping in that area, but also we'll be looking at aero mobility for the regional marketplaces in Asia. And finally, institutional marketplace, government type services as well. All of these will be supported by SES-9. So this is really a very, very big deal for us. It will be co-located at 108.2. It'll be co-located with SES-7, and it'll be basically taking over service from NSS-11 as we start to move services across onto the new satellite, which will give us better coverage, higher power, etc., etc. Now going back to the mission just for a moment here, and this is really where I'd like to sort of emphasize the relationship that SES has with SpaceX. We sat with SpaceX and said, guys, how can you improve our mission profile? How can you get us to orbit a little bit quicker? And so we have agreed with SpaceX that we will change the mission from a guidance-controlled shutdown at the 2nd stage to what we're calling a minimum residual shutdown at the 2nd stage. To de-technify that, and I'm speaking under Emily's control here, okay? So, anything, just, you know, shout or throw things, okay? What it really means is quite simple. We're going to burn the motor on the 2nd stage for a few more seconds. That's all it really means, okay? The big deal about that is that we're going to reduce our time to orbit by about 45 days. Initially, we expected to take about 93 days to get to orbit, but those few more seconds of burn will bring us down to about 45 days. So that being said, we should be in operational service towards the end of May or right at the very beginning of June. So that is a big deal for us. It's a very big deal for our customers as well. They're very excited. They want to get on with this. They want to get their services up and running. They've been waiting a little bit of time for this. But you know, the most important thing for us, the most important thing for the space industry, for SpaceX as well, is the reliability of the vehicle. That's really all that matters. I know we're a little bit late. Okay, fine. We can live with that. We move on. What's most important is that we get the perfect mission. And that's really the basis that we have this relationship on. So we'd like to thank you guys for helping us on that. And we really appreciate the efforts. So right from the pad, the rocket is actually horizontal at the moment. It was vertical when I left. It's horizontal again at the moment. We're looking for launch, as you know, tomorrow around about 20 to 7 in the evening. And at the moment, the only thing that's holding us back is the weather. We don't know what the weather's going to be like. We have a 60% chance at the moment of launching, predominantly due to clouds, maybe thunderstorms, and also for ground level winds as well. So that's what we're hoping that we're going to be good. Say 60% chance. Thursday looks better. We have 80% chance on Thursday. So with that said, you know, we're here, we're excited. It's the beginning of a new phase. For SES, as I said, 7 satellites under construction. That's an investment for us of around about $1.7, $1.8 billion. So it's a big deal. It's a really big deal. So this is really the start of the next phase of SES's development. And we're just very excited about this. We want to get this movement going. We want to get the next phase moving on, get this launch out of the way. Let's be successful and go forward from there. Emily, any words you want to add to that?
I think we should probably just...
With that, I mean, I can go into all sorts of technical details. I don't know how much you really want to know, but I'm here for a Q&A and happy to try and answer any questions that you may have.
The SES going forward in this phase, do you expect the longevity of this satellite as it is produced now to stay basically within the parameters it has been developed at this point? Or do you see it changing going forward as you launch future satellites?
It's a very, very good question.
And Martin, so can you repeat the question? Because not everybody's...
The question, and let me see if I can paraphrase it correctly. The question is, as we go forward with the design of our spacecraft and whatever, do we see the longevity of the satellite being as it's designed for today, so 15, 16, 18 type years, or is that what we'll be looking for the future? Is that correct?
It would be so, yes.
Okay, so, the answer is a very interesting one. We can build satellites that will last in orbit 23, 24 years. But think of this. When we design a satellite, first of all, we look towards what the business is going to be. It's all business driven. So we look at the business and we do an analysis on that. It takes us about 6 to 8 months. We then find a vendor to build the satellite. The satellite takes around about 3.5 years to build. Then we have the launch to go through. So from concept, 4 years in, we haven't even launched a satellite yet. The satellite is then designed ostensibly for around about 15 years. So you're looking at a 19-year span here. Now, let's all look back 19 years and where we were. You know, you think, well, hang on, is this going to be meaningful in times to come? So my answer is, and this is where I'm going out a bit on a track here, and it's something more on the innovation side that we're looking at here, is that we believe that our satellites have to be more flexible. We believe they have to have more flexibility on board and more adaptable on board to the demands that will come that we don't even know today, we don't even see today. My view is, it's a personal view, I think the cycle time of the satellites will go down to around about 7 years. And how we will do that is something which we're working on right now. How we will be able to modify our satellites when they're in orbit to have the capability to augment the payloads is something that we're working on right now. So we will launch satellites with the capability to have an interface, an accessible interface, where you can join another payload whilst it's in orbit to give it additional capabilities to basically keep it meaningful in the fast-moving data world. So yeah, it's actually becoming asymptotic. The longevity of the satellite is not the driving factor anymore. It's difficult from a business point of view to say, I'm going to do this over 7 years rather than 20 years, you know, because of the, basically the, depreciation of the spacecraft. But we believe that the cycle time and the reaction time has to come down. We have to make that thing far more meaningful. We have to keep it really accessible for the type of data services that we see. They're moving so quickly now. As we look towards 4G, 5G, etc. Terabit satellites are there. They'll be there in 2 to 3 years' time. we're going to need to be there too. So I think you're going to see satellites being cycled much faster.
Thank you, sir.
Sure.
James in Florida today. You gave us a big number for the value of all 7 of these satellites. I was wondering if you have a number for SES-9 specifically, or are they all about the same?
Nope.
Also, is this your first electric propulsion vehicle, and how does that sort of change the dynamics?
Okay, so the question is basically what's the price of SES-9, and how does the electrical propulsion element, is this our first electrical propulsion satellite, and how does that change the dynamics of our business case? Is that essentially the question? Okay, first of all, I can't tell you the price of SES-9. That's obviously information which we don't give out. It's an expensive satellite. It's expensive. From an EP point of view, from an electrical propulsion point of view, keep in mind that SES-9 is not an electric-only propulsion satellite. It's a hybrid satellite. We're also carrying, should we say, conventional propellant on board as well, which will shorten our time to orbit. And that's really, we're carrying around about 2.6 tons of fuel on board as well. So it's quite significant. The EP element, the electrical propulsion element, is only for the circularization of the orbit and the subsequent on-orbit station keeping. It'll still give us a lifetime in excess of 20 years.
Is the launch profile adjustment, the longer second stage burn save you chemical prop, to get to your orbit, or no impact?
Okay.
On the
It's a good question. So the question was, does this modification to the mission profile give us more chemical propulsion usage, basically, for later in the program? That's another, it's a little bit more complex than that. The chemical propellant that we have on board is only used for orbit raising. It's not used for on-station. So what we're trying to do is optimize the injection of the orbit that we use all of the propellants by the time we actually get to the final altitude. So that's the game that we're trying to work at the moment. And so that's a balancing game. With the discussion that we had with SpaceX, we hope to raise the orbit from the contractual number of around about 26,000 kilometers. We're trying to raise it to around about 39,000 kilometers. So we're going slightly super-synchronous, which means we're slightly above our final altitude, our final required altitude. And this will allow us to be able to reduce the amount of propellant, both electrical, xenon, and also biprop, that we actually use for the final orbit assignation. So it's an optimization of the use of fuel and the time that we need to actually use that. That's really what we're looking for. And as I say, that ends up at around about 45 days improvement. Big deal.
Hi.
Harry.
Could you just go through the flight profile, starting from main engine cutoff, how long the first burn and the second stage will be, and how long of a post, and how long of a
Do you have
second
that
stage?
information to
I
hand?
do.
Because I don't have it in my crib sheet.
Thanks. And I guess on a related note, obviously SES has not been shy about being first in line for any of the products or services that SpaceX offers, but did you get some confidence after the demonstration of the second stage restart? Is that important to you? I mean, we're expecting...
Absolutely. Okay, so did everybody hear the question? Do you want to repeat the question? It's probably easy you repeat it.
Go Irene.
Okay, well, my first question was about the launch profile, and then the second question was about confidence after a demonstration of the second stage restart.
Thanks, Harry. I'll leave you talk about the profile then, Emily. And for the second stage restart, sure, it always brings confidence. There's no doubt about that. We also have to turn back to our insurers, and we have to fly. We have to basically imagine that we're flying without insurance, and then when we are confident, we will turn to our insurers and we will show them why we're confident and the reasoning behind that. The second stage demonstration, of course, is huge, and it retires an awful lot of risk. There's no doubt about that. So that was very good, and it was very strong for SES, and it certainly, again, develops the relationship with SpaceX to have that sort of integrity. One thing I would also say is, in adversity, you really see how good a company is. And I think, and I'm not being negative here, I want to spend more time on it, but the recovery after the failure is when you really see. We've had the same situation with ILS and Proton.